So, folks, when you are going to build a circuit, I know we've been using something like these digital constants. Let's say you're going to do two inputs only. You would do this. And let's say for gates, we're just going to do the one AND gate. Oops. AND gate, two input AND gate. Let's say you have a two input AND gate. And for diodes, we'll get a light emitting diode. That's an LED. And it's something like this. But of course, we need a resistor before you put it in LED. That's always protocol. And those resistors are usually about 330 ohms. And you'll need a ground like this. And that ground wire is connected here. And you have a resistor. And this is going to be our one output. And there's not much logic here, just an AND gate. And so if you do this right, and we run the simulation, this light will turn on if both of them are on. So notice that light is on and both of them are on. If I turn any one off, see, off. If I turn this one off, it'll turn off. If they're both off, it's off. The only way to turn this on, because this is an AND gate, is this one and this one both have to be on. Now, how do you do this on a breadboard? This is not a good example because you don't have this little box that just sends ones and zeros out. You don't have that. Nobody has that. In real life, we're going to need a switch of some sort. Now, normally what we do is we do double pole single throws. Single pole double throws. We'll do these. Now, we don't even have these, to be honest with you, but this is the more common way you would draw these. And of course, you have to flip this. Yeah, you got to flip this one. And so you have this one output coming out like this. And then you have to go to sources right here. I think it's here. Here we go. Schematic connectors. I think this is the positive. And I think usually that's a positive. And then we need a ground of some sort. So let's just go ground and see if this works. And then, so notice that if I flip these switches up like they are now, they are connected to this wire, which is connected to the positive right here. That's the what's called VCC, or positive usually. Let's see if that's actually working here. Sorry, here I'm kind of zoomed in and out. So that does not seem to be working. Okay, so I need to make sure that this is a positive. Let's see here. Maybe it's here. Let's see. You know what? I'm going to use digital constants. How about that? So that'll be easier. So here's your positive. That's a 1, and we'll just do a digital constant down here. That'll be our ground. I don't know if there's another way to do this on this software. It's a little different than our regular software. Let's click the state on that. There we go. So this is 0, that's 1. We're not going to flip those switches anymore. So notice our light's on because this switch, so this wire leads to there, and this wire leads to here. And if you flip this switch, it turns off, turns on. Flip this switch, it turns off, turns on. And so if they're both off, obviously it's off. The only way this turns on is if this switch is on and this switch is on. Now, we're not even going to do these. We don't have single pole double throws. We only have single pole single throws. And so that's how we're going to do it. So how do we do this? Well, first off, that's an AND gate, which is a 74 LS08. Am I right on the AND gate? Yes, you can see those AND gates right there. So what you want to do is type that in and look at the images here. And that's what they look like inside. In real life, you have a bag of these. And in real life, they look something like these guys right here. Okay, so they look like these little guys here. What do they look like inside? So they have all these little pins, right? The first thing you need to do when you're wiring these things is you got to wire them correctly and stuff, and I'll show you that in a second. So the point is that when we're doing this on a breadboard, you'll need an AND gate. So quad NAND gate. No, we need this one right here. So we need the 74 HC08, and that's fine. We'll use an HC08. It's a different type of logic, but it's still AND gates right here. Okay. Pay attention to that little notch right there. That's important because that's super important because that notch has to be on the left side for this to match this drawing anyway. And notice we have to connect positive here and we have to connect negative here, ground. So let's do that. The first thing you do is connect negatives and positives. So if you look one more time, the positive goes here, VCC, and ground goes here, negative. So positive's up there on the top left. So let's go ahead and just connect some wires. So from here, we need to connect this to positive, and this needs to connect down to negative. So we'll make sure that our negative and positives are here. Look at this USB. It's got a little USB. We can actually use that to power this thing maybe. I don't know. Can we? That would be kind of cool. Ground, data. No, we want 5 volts. There we go. That's kind of cool. I wonder if this works. I don't know. We'll try this out as a power source. So we're going to use this as a power source. We're going to try to anyway. Let's see if that works. Okay, so right now this row has positive and it goes here, and there we go. And this row has negative and it goes here, and there we go. So this little chip has power now, so it should start working. That means that all of these gates, 1, 2, 3, 4, there's 4 AND gates in there, that they're all active and working, ready to go. For this project, we're just going to use one of them. Let's say we'll use this one here. So we're going to use that one. That means that this and this are inputs. See, input A, input B, and this is the output. Okay. So if we do an output, we can run a wire from here to here, and this is going to be our output, and we're going to put a resistor there. So let's see if we can go to search and put resistor. There we go. And here we go. And let's see if I can rotate this thing. There's a way to rotate it right here, I think. And we'll put it right here. So now the electricity comes out of here, out of the AND gate, into the resistor. This resistor should be, oops, there we go. I have to change the resistance. It should be about 330, right? That's because it's going to go to an LED. So let's go to 330, and then we need an LED. So we will put the LED here. Let's just search LED. There's a red one right there. That's good. But notice that this is the positive. Remember the longer leg that's bent? So we'll have to make sure that that one leads to here. So if we could, maybe we can rotate this around. There we go. That'll work. And we'll just stick it right in there. So now the output of the AND gate goes here, comes here, goes to the resistor, goes to the positive, and this one needs to be connected to the negative, and negative is right here, so we can just connect, see how that whole row is live? So we can just connect a wire from here to the negative. So now this leg is always negative. This one gets positive from the AND gate, it should turn on. If it gets negative, like a 0 from the AND gate, it should turn off. Now we got 2 inputs, right? So we got these 2 inputs, and I need 2 buttons for those inputs. Here we go. How do we do buttons? So let's get a button. These are the kind of buttons you have in your kit that you're getting. And there's 1, and there's 2. We'll need 2. Okay? And they'll need positives when we push them and negatives when we don't. And that's very important, okay? So what I need is a positive wire to go from here to anywhere here. So when I push this button right here, it will come out here. And when it comes out here, it's going to go, let's go to this one. So that's that first input. But when you don't push it, I need negative. Now, here's the thing. Do not get confused. See, a lot of students think, okay, it's positive. And when I push it, it gets positive. When I don't, it's negative. No, it's not. When you're not pushing it, it's nothing. And that's not negative. That's not a 0. That's like an undefined state. So I need it to be negative when I'm not pushing it. So here's how we do that. We get a resistor. And I'm going to get 2 for this. And I'm going to need another one. I'll show you because we're going to do both buttons. Now watch this. This is a 1K resistor, this is a 1K, and that's fine for now. So think about it. If I'm not pushing this button, is positive coming through here? No, it is not. So what is this getting right now? Negative, this is negative down here. Negative goes through this resistor, kind of slow, but it goes to this wire and goes into there. So this is a 0 now. When I push this button, the positive comes through and comes through here. Some of it even flows through this resistor and comes through and just gets wasted and goes just down here and just cycles through the whole circuit going through this resistor, but not very much because remember, it's a resistor. So this is what we call a drop down resistor. What happens is when I'm not pushing, it's sending a little trickle of negative. When I push this button, there's no resistance here, and positive floods the circuit with positive and becomes a 1. Some of it even gets trickled through the circuit, but that's fine, no big deal, it's a little bit of a waste. So this is how we do it. So this button is ready to go. Now I need this button. So let's go a little positive right here. And when I push the button, it'll come out here, but I'm going to drop it down here because I'm going to run it to here because I need to go to this input. So it goes here, perfect. This should be working. Let's see if this works. I don't know if this thing works here, but let's see. Let's push start simulation. This thing burnt out. What happened here? I saw a little fire. Did you guys see that? Look at that, it exploded. I don't know why. Why would it do that? This is positive, this is negative. I don't know, maybe that's just a glitch. Let's see what happens when I push these buttons. So right now, notice I can't push both buttons at the same time, right? It's not letting me. That's weird, right? Well, because I can't. I don't know how to click both at the same time in this simulation. So what I'm going to do is just kind of cheat, and I'm going to stop the simulation. And I'm going to at least run one positive directly to here all the time. There we go. So this button's being pushed automatically for me because the positive is not going to go through the button. It's kind of cheating, just jumping over here and going over here. Some of it is going to get wasted. That's fine. So let's see if this works. Start simulation. Oh, look at that. It works. Do you guys see that light? When I push it, it works. This one's not going to do anything because it's already on. So it seems to work. So I'm going to go ahead and delete this wire. And you'll notice that pushing the buttons don't do anything. Oh, sorry, start simulation. Pushing these buttons don't do anything individually. I have to have a button. It won't let me draw a wire while I'm in simulation. I have to have one here, and I have to have one here. Well, for this one, I could just push it, and there we go. So you're going to have to draw this and build this with a real one, okay? So let's go over it one more time. We have a integrated circuit, for you guys, it's a 74 LS08, and 08s are AND gates, okay? And you can see this right here, 74 LS08, and this is what they look like inside. We're going to be using this little AND gate right here, these two inputs and this one output. But make sure that we connect positive and negative for this to work. Otherwise, this thing doesn't work. Just to power it up. And let's delete this real quick because that's not part of your circuit. So let's follow along everything. So first we need negative here in this whole row. See, it's all green, all these little greens. Negative here, positive here. Then this thing needs power just to work. We just need to do that every time before we even start. We put a positive here. And we put a negative here. Warning, 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 warning. Triple check that you're doing this right. If you put this backwards, this will get hot. It'll burn your finger. It'll destroy this integrated circuit. It's completely worthless and trash at that point. So do not do it backwards. Pay quadruple attention before you power this up. Look at this little notch. There's a little notch here. And this little guy right above it should be power, positive power. And this bottom right one should be ground, negative. Got it? It will only work that way. If you do it backwards, it gets hot and just burns up, and it'll burn your board and it'll burn your finger if you touch it. So be careful with that. Now, once you have that powered up, remember we're only using these three because we're only using this one little AND gate that's in here. You can't see it. And we're going to have this one output, and it's going to go over here through a resistor into the positive side, the anode of the LED. That's the long leg. And then it goes into the light, comes out this side to the negative. And if this sends a 1, which is positive, it will turn this on because there's a positive here, a negative here, and it'll turn on. If this sends out a 0, which is like a negative, then a negative here and a negative here won't turn on. So that's how that works. Okay, so that's the output. Then we have two inputs, here and here. This one is coming from this switch. And it's simple. There's a positive wire right here, so positive. It goes down. And when I push this button, the positive goes through diagonally, goes in here, and goes right into here. Some of it, yes, will go into this resistor and flow through to the negative and just kind of like warm this resistor up and waste. No big deal. When I do not push this button, super important that we have this negative resistor in the negative, and it will trickle a little bit up to here and sending a 0 signal saying to be off. Same thing here, exactly the same thing. Positive over here, travels through here. When I push the button, it goes diagonally, goes in here, and travels to the other input. And some of it will get wasted into the negative side. That's totally fine. And when I do not push this button, so there's nothing flowing through here, there is something flowing here to here to here, and that's going to be that negative coming from here. And that's how this works, okay? And then, of course, we just need a 5-volt power supply. If you can do 5 volts, that's what we need. We need something from a USB. You guys, that's where all your power is coming from so far. You use that USB tester, and you have a positive and negative, and it works. And that's how we get our 5 volts from. That's what we want to use for this. And that's it, folks. So do this like this, and turn it in. Plus, do it in real life with a real AND gate, 2 real switches, 2 resistors. These can be 1K each, 1,000, 1,000. That's totally fine, or 2,000. Don't try to go too high. It doesn't work. And too low is maybe bad too. And then here's 330, about 220, whatever. Something to protect this LED from burning out. And that's pretty much it. Make sure you pay attention to this. That's a 74LS08. You have about 5 different kinds in your bag when you pick them up from the library. They should be outside in the library, and make sure it's the one that says 08 at the end. Those are AND gates, okay? And that's it.